So far we've talked about the three different forms of a quadratic: factored or intercept form, standard form, and vertex form. And we've talked about them in relationship to the graphs and what they showed. Factored and intercept form show the x-intercepts, standard form shows the y-intercept, and vertex form obviously shows the vertex. But sometimes it's helpful to convert from one form to another algebraically, which is what we're going to look at in this video. One thing that can help is to cover up the y equals and think about what you'd usually do. So if I imagine covering up y equals in the first problem, you have two binomials being multiplied together, which usually we would multiply out using either FOIL or the area model. So what I'm going to do is jump down here and put my y equals, and I'm going to multiply my two binomials together. 3x minus 1, x plus 4. So I get 3x squared, negative x, 12x, and negative 4. When I combine like terms, I get 3x squared plus 11x minus 4. What's different with the next problem? I notice that there's a negative 2. So what I'm going to do is bring down that negative 2, and I'm just going to have one extra step in this problem. I don't want to distribute it right now, because a lot of times what I see is people distribute to both parentheses when really you just need to do one, but I like to just take in a couple steps. Now what I'm going to do is focus on just the two binomials and multiply those together. X plus 2, 2x minus 1. So 2x squared, 4x, negative x, negative 2, and I put that in my parentheses I have already down here. 2x squared, 4x minus x is 3x, minus 2. And now my last step is to distribute my negative 2 that I have in front. So y equals negative 2 times 2x squared is negative 4. X squared, negative 2 times positive 3x is negative 6x. And negative 2 times negative 2 is positive 4. Hopefully, changing from our factored to standard form wasn't too bad. And the same thing is going to go to vertex to standard form, as long as you don't try distributing the x squared into the parentheses. You can never, ever, 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 ever do that if you have addition or subtraction in your parentheses. That's what I have on my wall that says it kills puppies. Don't kill the puppies, think about the puppies. So what is really in front of this parentheses is a 1, and you'll see why I do this in the second problem, but I'm just going to bring down the 1. I'm going to multiply out my binomial and bring down the plus 6. I promise once you've done the first step, then you will have probably forgotten about those other numbers in your problem, which is why I suggest doing this. So I'm starting with x minus 2 squared. What that means is a square with sides x minus 2, or x minus 2 times x minus 2. Either way you want to think of it. So that's going to give me x squared minus 2x minus 2x plus 4. I put that in my parentheses. X squared minus 4x plus 4. Now, when I distribute my 1, it really doesn't do anything. So I'm just getting x squared minus 4x plus 4. Still bring down your plus 6, and maybe you can see what we're going to do. I've been leaving off y equals, so I'll add that back in. So y equals x squared minus 4x, and 4 plus 6 is 10. The most important thing, once again, is not to try and distribute that squared, because what happens when you distribute the squared is you lose your diagonal, you lose that middle x term. So your answer is wrong. Don't distribute it. Okay, so we're going to do the same process on the next problem. I'm going to skip some space and bring down my negative 3. I'm going to leave some space for when I multiply that out, and go ahead and bring down my 10. And now I'm going to multiply out my binomial that is being squared. Now some of you are going to get to the point, and we'll talk about in the next unit, a pattern that we can use to multiply that binomial out in our head. And if you know how to do that, then obviously that's fine. Just don't distribute the squared. So x squared, 4x, 16. So x squared, combine your diagonal, 8x plus 16. Now I didn't promise all these numbers are going to be like super happy, as you can tell. So we're going to distribute. So negative 3x squared minus 24x minus 48. Don't forget about your plus 10. So y equals negative 3x squared minus 24x minus 38. So basically when I'm going to standard form, my goal is to be multiplying stuff out. When I want to go from standard to factored form, what do you think we need to do? We need to factor. And I want to remind you of a couple things. Always look for a GCF first. And be careful when we have a negative x squared. I'll show you what to do on the next slide. But we need to be careful of that. And then don't forget about your shortcut. Your shortcut you can do when there's a 1 in front of your x squared. And when there's a 1 in front of your x squared, that's where you can just be doing the x. I just suggest getting used to when you can do the shortcut, when you can't, because a lot of problems you can do the shortcut and it'll make your life easier. But obviously we want to be careful and not do it when it doesn't work. Okay, so if I look at my first problem, I don't have a GCF, and I have a 1 in front of my x squared, which means I can do my shortcut. So for your shortcut, you're going to do 1 times 20, that's what goes at the top, and b still goes at the bottom. So what two numbers multiply to 20 and add to 12? Hopefully I give you like nice ones on these so that we're focused more on just the overall going to the form. So y equals x plus 10 times x plus 2. Remember, in our shortcut, you're just bringing your side numbers down. When I look at the next one, what do you notice? They're all divisible by 2. I try to give you really obvious GCFs, by the way, when it's something like this. So I'm going to take out a GCF of 2, which is going to leave me with x squared plus 2x minus 8. And now what I do, once again, you're probably going to forget once you've done more of the problem. Bring down that 2. And now I'm going to focus on the inside and do my x there. So what two numbers, look, I can do just the x because it's a 1, multiply to negative 8 and add to 2. Well, that's just going to be 4 and negative 2. So we're going to bring that down and put our binomials, x plus 4, x minus 2. What for a loop for on this one? Look what I have in front. I have a negative 1 in front. Anytime we're trying to factor and I have a negative in front, you want to take out that negative, almost like it was a GCF. I just pinky promise this is what you want to do. X squared minus 2x minus 48. 99% of the time when someone is doing a problem on a test and they can't get it to work and they bring it up and they go, Miss Vance, this problem doesn't work when I do the x. It's because you didn't take out your negative 1 because it messes up my signs. Okay, done with my lecture. Negative 1. Now I look inside my parentheses. I have that 1 still, so I can do the shortcut. 1 times negative 48. It's obviously negative 48. I like 46, so it looks like a 46. Woo! Negative 2. That's going to be negative 8 times 6. So x minus 8, x plus 6. Done. Now, these two aren't on your page, and I know it's probably really squished. I'm sorry. But I wanted to add these because we get so used to doing the x that we kind of forget about some other ways of factoring. So look at this first one I wrote. What do you notice about both of them? Well, they're both divisible by 4. They both also have an x. So this is just a GCF problem. I get 4x times x minus 4. So don't forget about Mr. GCF. And then also don't forget about this one. It's just a little difference of squares. Difference of squares is going to become your best friend. So don't forget about difference of squares. Promise. It ends up being really important. Now we get to the big one, which is going from standard to vertex form. And we've talked about in class that vertex form looks a lot like when I was solving by completing the square. And so what we're going to do is a modified version of completing the square. But since I'm not solving anything, I'm not operating on both sides of the equal sign. I'm operating on one side of the equal sign, which means instead of before when I was completing the square, and don't write this, and if I got 16, I would add 16 to both sides. Now I'm going to minus 16 because my goal is I'm adding 16 here, and I need to take away the 16 because I'm operating on the same side of the equal sign versus opposite sides of the equal sign. You'll see what I mean. So what we're going to do, I am focusing on the first two terms. So I'm going to draw this little dotted line right here, okay? We're not worrying about the constant. You're going to get so confused if you pay attention to that 11 over there. And what we're going to do first is always put the opposite of a, the opposite of whatever I have in front of x squared. So the opposite of what I have in front of x squared right there is -1. And then I'm going to leave a little blank right here. So I put that on the other side of my dotted line right underneath the 11. And now I'm going to focus on just the x squared plus 10x. And I'm going to complete the square like I normally would with x squared plus 10x. So usually I would put x squared in the top left box. Then I would split 10x in half and get 5x. We would factor that out and get x plus 5, x plus 5. I'm going to bring down, I had 1. Then I have my two binomials, x plus 5 squared, and then I have my gaping hole, which in this problem would be 25. And that is what is going to go in my parentheses right there. And then I can simplify my constants. So 11 minus 1 times 25 is the same thing as 11 minus 25, which is going to give me -14. And I have my vertex form of my parabola. And you're done. That's it. So the key difference between when we did it to solve is that I'm doing this opposite thing right here. That's the key difference. And that's, once again, because I'm on the same side of the equals. I didn't do anything over there with y. There's a way that you can move it over there with y, but then you have to remember to move it back, and it's just a couple extra steps. But I can show you in class how to do that if you'd prefer. So start off, draw your little dotted line, because we're ignoring that -2. I have a +1 in front, which means I'm going to put -1 something. And now I'm going to complete the square on the left side like normal. So x squared goes first. 12x gets split into 6x. And 6x, x, 6, 6. So I'm going to bring down that 1. You'll see why later. 1 times, I have x plus 6 squared. What goes in my gaping hole to complete my square? 36. And that gets filled in, whoops, not negative. That gets filled in my spot. So I get -2 minus 36, which would give me -38. Alright, don't forget your y equals, because this is an equation. Alright. So we're going to change it up a little bit on the next two problems. Well, not really for this next one. So if you want to pause and try this next one, this would be a good one to try. So opposite of A, do your box, x squared split in half, -4x, -4x. So I get y equals 1 times x minus 4 squared. Gaping hole is 16. And 6 minus 16 is negative 10. All right, now what is different in the next problem is that we have this 2 in front. We're not thinking about 2 as a GCF, okay? Don't think about 2 as a GCF. We still are going to start exactly the same. Dotted line. We're doing the opposite of A, so in this one it's negative 2, and we're going to fill that in. And now what we want to do is take the 2 out of the left side only. 2 out of the left side only, which would give me x squared plus 2x. Okay, I emphasize that because obviously you're going to get confused if you're paying attention to that negative 7. We're ignoring it. And also we're taking out the 2 because it's what's in front of the x squared. It's not because it's a GCF. I'm a nice human being, so it is always going to be divisible into your x term, but it doesn't necessarily have to be the case. So I'm going to jump down here to where my answer is. Do you see this 2 in front? This is why I keep writing the 1, because a lot of people forget it. So I'm going to go ahead and do it right now. Now I'm focusing on the inside and completing the square with that. So I have x squared. When I split 2x, I get just x. So that's going to be x plus 1, 1. So x plus 1 squared. And then 1 times 1 is 1. So what gets put in over there is 1. If you need to show your scratch work, negative 7 minus 2 would give me minus 9. Last 2. Here I'm trying to tempt you because on the last one the 7 wasn't divisible. The last term wasn't divisible, but here it is, and so someone out there is tempted to divide it, but we're still not going to. Opposite of positive 2 is negative 2, so always start with the opposite of A. Now with these, if there's something in front of x squared, we're always going to take it out. Once again, it's not that it's a GCF, it's that it's in front of x squared, but I'm going to be nice and they're going to be GCFs. Otherwise we get lots of fractions. I try to be nice sometimes. Alright. I'm going to go ahead and bring down that 2 so I don't forget it. Now let's complete the square. X squared, split the negative 4x in half, so that's negative 2x, negative 2x, x minus 2, minus 2. So I get x minus 2 squared. Fill in your hole, so that would be 4. Then just compute. Negative 6 minus 8 would be minus 14. And you're done. The last way I can try to trip you up is if I put a negative. This is why I keep saying opposite. So the opposite of negative 3 is going to be positive 3. So it's not always minus, it's the opposite. Now we're going to factor out that negative 3. So negative 3 is going to leave me with x squared plus 4x. X squared plus 4x. Go ahead, jump some space, and bring down that negative 3 because you're going to forget about it. Let's do this middle part. X squared, split the 4x, 2x, x, 2, 2, so x plus 2 squared, then that's going to also be 4, 4, if you need to show your work, 3 plus 12, whoops, ran out of room, so plus 15. This one, the key is when you take out this negative 3, this is a positive 4. So make sure that you are changing that sign.